Now, one thing I said is that we would come back to this bridge ID value. And so I want to talk about that a little bit. And we were looking at just the MAC address as finding the lowest one as the bridge ID. But there's a little bit more to it than that. And once you've figured out how to do the spanning tree protocol with just the lowest MAC address, then what we really want to do is we want to look at this idea of having a priority value. Now, because of the fact that I don't really have a lot of control over what the MAC addresses of my switch ports are, and those are determined at the factory. What the engineers who created this spanning tree protocol wanted to do was they wanted to return some of the control um, back to the routing engineer and say, even if you have a really weird MAC address that's totally different than all your other, totally lower than all your other devices, right? Or you replace a switch or something, you're going to be able to control what happened by changing the bridge priority. Okay, and so I want to talk about that and how it works. Now, this is part of that um, idea of what happens when this switch boots up from a state of nothing, and how does it make a determination on whether or not it is the root bridge. And what we do is when that switch boots up, when in this particular case, these are all of our switches that we created in the previous video. If I cut power to all of these devices at one time and they all booted up at the exact same time, right? What is going to happen is that every single one of them will think, I am the root bridge. I am the boss of this show. Every single one of them will have that idea. What they will do is they will then the ports will be in a listening state. They're going to wait to hear from another device that's connected. The switch will know that there are devices connected to the other links, but it's going to wait for a minute to hear from the switch, and it's listening for that BDPU, that Bridge Data Protocol Unit, that's going to wait and come, and it's going to give me some information. Mainly what's going to happen is it's going to give me two pieces of information. It's going to give me the bridge. It's going to give me the bridge ID. Okay, and so this thing is a priority value, and it is a extended system ID, which is just the VLAN number, right? And then the MAC address. But with the priority, every switch starts at the same priority. So when we boot up, the priority value is 32768. That is in the middle of it's in the middle of a 2-byte value at that point, right? So that's the middle value of 2 bytes. It takes me one more bit to get to 65,535. Okay, but anyway, this is just right in the middle. And the reason why the engineers who created this protocol decided to do that is because they wanted someone to be able to move up or down in a particular range and adjust this value. And they wanted to do it in such a way that they didn't have to go and calculate and do a lot of calculations. Right? So they put this 4-bit value right here, and it says, okay, the first bit's going to be plus or minus, and then the other 3 bits are going to be some number from 0 to 7 of 4096. Right? So if I have a 0 there, and I'm not actually modifying this value at all. But if I have a 1, and it's 4 bits, so I'm going to have 4 spots. So if I have a 0, 0, 0, 1, then what actually is going to happen here is I'm going to subtract, or actually no, I'm going to add 32,768 plus 4096. I'm going to get a bigger value. And I'm going to do this on my calculator because I don't do that very well in my head. But especially when I'm recording a video. But anyway, here's my bridge priority ID. Right? So you don't have to memorize this bit pattern. Right? Just know that it goes in steps of 4096. So I can make that higher or lower. Right? If I keep adding 4096, I can only add it a certain number of times before I get to 0. In this case, 8 times, right? Or I can only subtract it 8 times before I get to 0. So that's what we have here, right? This counter tells me how many times I add or subtract 4096 to increase or decrease my priority value. So it just makes it an easy way, right, to have something. I can set it. I can set a very simple value in the switch, and all of a sudden my priority field is lower, and it overrides this MAC address. It's going to override it because this becomes much lower. So if I want the particular switch to always elect itself as the root bridge, I'm going to get this value as close to 0 as I can. Right? I want it to be low. If I want the switch never to elect itself as the root bridge, I'm going to get it as high as I can. Right? Which is going to be right here, 65,535. I'm going to get it as high as I can, so I want to change these to 1. Right? That's what I'm really doing is changing this priority so that I'm overriding whatever's in the MAC address. Okay, and so that allows me to have some pretty granular control over which switch gets elected on the root bridge. The other thing that I have here in the middle value is a VLAN number, and the VLAN number allows me to do the root bridge election on a per VLAN basis. So because the VLAN is always 1 at the default, this value is always going to be 32768 plus 1, or 32769. Okay. If I change the native VLAN, I'm actually changing the bridge ID priority on the switch. But at that point, I have different VLANs in my switches, so it doesn't change. But that's what our bridge ID actually is. It allows us to have some both granular control, more granular control over which switch gets to be the root bridge, and it allows us to do it on a per VLAN basis, which we will get to per VLAN spanning tree in a different section, which is right here, 5.2.11. So thank you, and if you have questions on VLAN spanning tree, of course, you want to just send me an email or ask questions in the lecture, at the end of the lecture. Thanks.